If you've ever tried programming in Unity's UNET and you've used something called the network transform, or you've tried many different ways to sync movement over UNET, you'll notice that there's a lot of problems and you might get some movement similar to this. You'll notice it's a little bit blocky when it moves, it's kind of snapping. If I start moving the player, it starts snapping in different intervals. It's not like the smooth movement that you see over normal multiplayer games. So now, there are a few things that you can do to solve this problem. The most common way that I've seen is that somebody will create a sync var of the actual location and use client RPCs and commands to lerp between your current position and the sync var, so that it makes it look like the multiplayer movement is synced. However, there's a few problems with this approach, and I find that first of all, although sync vars are very, very convenient, I don't think they should be used for something like movement, simply because sync vars update every time you change the variable. So that could potentially mean hundreds of updates per second, if I'm understanding how they work correctly. If not, somebody please feel free to correct me in the comments. But as far as I understand it, they update basically every time you change it. So if you have a multiplayer game of 20 or more people and you're constantly running around and constantly sending new updates, that can be a lot of network traffic you don't want to deal with. Now, using a network transform, you can adjust the send rate, but if you're constantly lerping the position with a sync var, then you will always run into the problem of a cluttered network. So, and sometimes that approach doesn't even work for people. I personally had a lot of trouble getting that approach to work. So I'm going to show you guys my fix on how I like to sync multiplayer movement, especially when it's movement that is happening all the time. My approach is a little bit different because I avoid using the network transform altogether. I implement my own version of it using Unity's built-in messaging system. I'm going to give you a brief overview of a project that I have, and then I'm going to go through it with you and teach you the proper way to use lerp, because a lot of people are using lerp using the float variable. They'll use like time.delta time, or they'll use like a lerp speed or something like that. And this isn't the proper way to use it. You can do it that way, but there is a much, much better way to use it. So first, in the description, I'll have a link where I will have the commit for this version of the project ready for you to download so you can work along with me. I've already created a few files. I've created some of the elementary stuff. I just wanted to get it out of the way. Just because I didn't want this tutorial to be 2 hours long. So I have 4 files here, and I'll show you what each of them do. So the very first thing I want to show you is my network message handler. It's a network behavior. It has a constant short, and it's declaring a custom message. You can use any number basically above 100 to be safe. I just use 1337 for obvious reasons. And I also have a custom Unity network message declared here. Since this is a more advanced tutorial, so I'm not going to get into too much detail about how it works, but I will also give you a link to how to define these and where these are defined in the UNET documentation itself. So I have my custom player message here, and how this basically works is every time the local player moves, I check to see if I can send a network movement update. And my restriction for that is I've set a network send rate similar to the one that you would see on the network transform. For example, the default Unity network transform send rate is 9, I believe. I just brought mine down to 5 just to show you for tutorial purposes. So this network message handler is a network behavior. And the reason I want that is because I want my server relay, the server part that's receiving and sending the message to all clients, and the client itself to be receiving it. So you'll see that my network player is inheriting from network message handler. That way it can see all the classes on the inside and I don't have to include anything else. So what I've done here is I've set up basic ship movement properties, basic camera properties, and I'll just go over this a little bit. So whenever a player spawns on the network, it will create the prefab of the player, which this class is attached to. So right away, it's going to say, hey, you're player, and then get the connection ID. So let's say player 2, and it's going to add you to the local player manager. So every client plus the server has a local player manager. And basically what the player manager is, it just keeps track of all the players in a dictionary. So every time somebody connects to the game, The object will be spawned on all the clients, and every client will have a copy of that player inside their connected players dictionary. You'll notice here too, this static class, this manager has a player ID. What this is used for, that this is my local player ID. So whichever manager this is on, whichever client, we're going to set this player ID to that transform. So for example, if I'm the local player, let's set the local player ID, which in player manager sets our player ID. Very simple. Also, since we're the local player, let's get the camera hooked onto our player and let's register our network messages. So if you've read through the UNET messaging system, if you haven't done that now, I suggest you pause that and you go take a look. I'm registering my message on the client side here. So anytime I receive a network message, I want you to call this movement message right here, this on receive movement message. And what this does is it grabs the message, it checks to say, hey, we aren't the local player. That's what this is doing right here. And if we're not the local player, let's go to the local player's game manager, find the correct player that this is meant for, and send the movement message. Very simple. So right now, when you saw the cube in the beginning teleporting around, you saw basically this. It's just every time we receive the movement message for that player, just move it to that transform, position, and rotation. So this is what we're going to be using, this information, to actually make the movement look smooth. So most people, when they make these tutorials, they get the lerping part right. Lerping is kind of what you have to do if you're just making a basic UNET video game, sorry. But to get into more complicated games and games that are a lot more expensive, you have a whole design team taking care of this. But if you're a small team, lerping is the way you want to go. So just a few more things. If we're the local player, we want to update our camera and update our movement. Now, one last thing I should tell you about. Our network send rate and our time between, and these two variables calculating the time between the movement. This is very important for the lerp to work properly. So I have a network send rate of 5. What I mean by this is I want it to send 5 times every second. Pardon me. So if I go down here to update player movement, after I get all my input and do my translate, my rotate, hey, let's check if I can send the network movement. Because if I can, what I want to do is I want to take the time at the beginning of the movement. I want to wait the desired. Sorry, this is to reset the Boolean. Sorry. If what it does is it checks if we can send to the network. If not, let's flip it to true where we can send. Then let's start this coroutine. What the coroutine does is it calculates. It waits for the time between sending. So for example, my network send rate is 5. So I have 1 divided by 5 here. So I want it to send every 200 milliseconds. So once 200 milliseconds goes by, then it sends the movement. Then we take that end time. So basically we get this time and this time, and what we're doing is we're subtracting them here. So we can get the exact amount of time it takes for me to send the message. Now, normally you would say, okay, why don't you just use this variable right here? Because that's the amount of time it's taking it's the time between movements, the time it takes to send the message. The reason why we don't do that is because obviously it's not going to be precise. This will give you a higher decimal value and will be more accurate. That's the reason we want to do that. And then we turn this to false again, and then it starts to switch and it starts this whole process over again. So once this hits false, then this coroutine starts again. You wait another 200 milliseconds and then it sends your movement again. Pretty simple. This last part here is how we send the movement message. Again, if you've read the Unity documentation, good for you. If not, I suggest you go there and read what I'm doing here. So one last thing to show you is the server relay. It's very simple. We check it for the server. If so, register the movement message. And anytime we get a movement message, simply send to all clients. That's what this send to all does. Very simple. We don't really have to worry about it. If I go to our online scene, I've created a server object, which has server authority, and that's where the script sits. It's just a relay. That's all we need to do on the server for now. So, as I showed you before, the cube is slowly teleporting between its rotations and its positions. So now what we're going to do is we're going to take the information we're sending and we're going to use it to lerp between our positions and rotations. So let's go to our network player and let's create a bunch of variables. Let's call this lerping properties. And let's use capitals because we're proper like that. So you're going to need a public bool is lerping position. Public bool is lerping rotation. A public vector 3. And if I remember to do this correctly, it's our real position. Pardon me, I kind of have a cold right now. Our public quaternion. Quaternions is how Unity deals with your rotation. We're going to call this real rotation. Then I'm going to copy these guys. I'm going to say last real position, last real rotation. We're going to be lerping between these two variables, and these are going to be constantly being reset to new variables every time we receive a movement message. This will become more clear as we go through this. So I think I just need 2 more floats. One is the time started lerping. This is important so we get the timing correct, and this is how long we want to be lerping for. All right, so now in the start function, so if we're not a local player, then we're going to want to be doing our lerping magic. So let's do an else here, and we're going to set our lerping variables here. We're only going to be lerping if we're not the local player. So this never happens locally. This only happens for client prefabs on the other machines. So let's do is lerping position. Let's set that to false because we're not right away. Same thing with the rotation. We are not lerping when we start. We're only going to start lerping when we receive a movement message. So the very first real position is going to be equal to our transform.position. And that's because that is our real position right now, and that is the first one that we are going to be lerping from. Same thing, the rotation, if you haven't guessed it already. A lot of this is just going to be a carbon copy of each other. The position and the rotation, there's not much difference. Okay, so that looks pretty good. So the next thing is when we receive the message. You know, I'm just going to rename these because I can't stand having names like this. Let's call this time to lerp. Sorry, I'm just very OCD about that. Okay, so what we're going to do in here is basically we're going to set our positions. We're going to check to see, hey, if our positions aren't equal, let's start lerping. Same thing with the rotations. So we're going to set our last real position equal to our real position. We're going to set our last real rotation to our real rotation. And that is because we want to be lerping from our last known real position to the one that we are receiving inside the movement message. So let's go real position is equal to underscore position. So our real rotation is equal to rotation. And as before, this was unused, but we're going to be using this now. We want our time to lerp. Again, this would normally be 200 milliseconds, but setting it this way, you get a more exact variable, and it makes it look a little bit smoother. So what we're going to do is we're going to say, hey, if our real position is not equal to our transform position, so where the transform is now, that means we got some lerping to do. So let's set our lerping position equal to true. Oh, can't compare quaternion and a vector now. Sorry about that. Next, we are going to check to see if our real rotation is equal to our transform rotation. Now this is actually a mistake, and I'll correct this in a second. And then we're going to set is lerping rotation equal to true. Now, when I originally tried this, I was getting a lot of errors, but for some reason, when you compare two quaternions straight up, Unity doesn't like it. So what I do is I just hack it, and I just compare the Euler angles, which essentially is just the numerical values instead of comparing the entire quaternion itself. Don't ask me why that doesn't work. I've looked into it, never really got an answer out of it, but we just want to compare the Euler angles. It's just a lot cleaner this way. The last thing we want to do is we want to say our time started lerping is equal to time.time. We don't really have to put this in a check or anything. We always want this to be reset when we get a new time value. Pretty simple. The reason that we have these checks separately is because our rotation might change, but our position might stay the same. So I think that seems pretty obvious. Okay, so we got the receive message. Now, the next thing that we're going to do is we are going to go to our underneath this, and the next thing we're going to do is we're going to do our fixed update. Now, we're going to say, hey, if we are not the local player, we want to do something. And we're going to make one more function, and we're going to call this our network lerp, just to be clear about what we're doing here. Okay. So, let's see here. So what we're going to do is we're going to call our network lerp here. Now, you're probably wondering why I'm putting this in fixed update. The reason why this is going in fixed update is because fixed update is not frame rate dependent. Update can skip sometimes, and you don't want your update function to be handling the lerp because you want it to be handled as precisely as possible. Otherwise, you're not going to have a proper representation of where players are on the network, or they're just going to be bouncing around and it's not going to be pretty. But if you put in a fixed update, everything's going to go just fine. So we're going to have two conditions here. We're going to say, hey, are we lerping our position? Sure. Hey, are we lerping our rotation? Sure. And what I'm going to do here is I'm going to say, hey, lerp percentage. So, you know, I'm going to type this equation out first, and then I'm going to explain to you how the lerp is actually supposed to work. So basically what this equation is doing is I'm checking how much time has gone by, and I'm dividing it by the time to lerp to get the percentage that I want. And the reason why I want this value, which is going to be between 0 and 1, is because how the lerp works is, let's write it out. This is what most people get wrong about lerp. I'm not saying it comes to syncing movement, I'm just saying in general. So let's take, we want to lerp between our last real position, our real position, and then our lerp percentage. So what this is basically is the percentage, the number between 0 and 1 you have right here, you can look at as a percentage. So for example, if I have 0.56 as my lerp percentage, or 56% of my lerp, what this means is that this position is going to be 56% of the way from this to this. So if I had like a time.delta time value in here, it's always going to be just sticking close to this value because it's an extremely low decimal number. Or if I had, let's say, I don't know, 0.9. It would always be approaching the end, but it would never quite get there. So what you want to do is you want to make sure that this is a percentage. And that is why I'm sending the time between each lerp. Because determining how much time has gone by can tell me what percentage of the lerp is supposed to go by. So we can just do a little copy pasta here. But instead of position, we'll do transform rotation. We'll do last real rotation, our real rotation, and we'll just change this to a quaternion. So essentially, this is the exact same thing with the rotation. We want the percentage. We don't want some fixed value. Otherwise, it's not going to give us the desired effect we want. Not in this case anyways. When you want to sync network movement, you always want that lerp to reach the finish line. Otherwise, you'll never have a proper representation of where that other player is. One thing I haven't added yet is the condition to make these false, but we'll just put that in a second. So I think I have everything. So we can go out and test this and see what happens. Hopefully I didn't break it. So let's go back to Unity. Any compile errors? Okay, good. It likes me so far. Let's just hit Control B. We'll get that build going. Okay, we're gonna hit play. We're gonna hit play here. So I'm gonna host it here. And whoops, I'm in the wrong scene. You gotta go to the offline scene. We're going to connect with the client. Okay, so I can see the client here. I can see the other guy here. So if I start moving, let's say on this screen, you should see a lot smoother movement than that snapping that we had before. So let me put this here. Let me start moving on this guy. So as you can see, it's not snapping back and forth. It's actually changing the directions. It looks like it's lerping. It's being smooth. So let's test the rotation now. So let me move up a little bit and stop it. As you can see, it's pretty responsive. You can tell that this is a couple milliseconds behind. I guess that would be the equivalent to what your ping is. So if I start rotating this here, you should see it start rotating here. And when I let go of it right now, it just finishes the lerp spinning. So it's a pretty good representation using just the lerp and not any advanced mathematics or rotation or position prediction. So if you want, also in the end here, you can add the condition to turn these false. It's I didn't put it in yet, but if you did, it would just simply be if our lerp percentage is equal to or greater than 1. Just why doesn't it like that? Did I not spell that right? Oh. Creator has to go first. Wow, stupid me. Anyways, you would just set this to false. Pretty simple. So that's all you'd have to do to cancel that. But yeah, there you have it. So instead of using the network transform, I declare a custom message class. Like I said, I'll link you to the description in the beginning if you never played with those before. And what I do is I lerp between the last position and the real position, like I've shown you. And I think it gives you a pretty good simulation of networked movement. Now, there's one more thing you might ask, is that can we do the same thing to sync rigid bodies? I'm not sure. I've never tested if you can sync rigid body, for example, the velocity of a rigid body over the network. I don't know if it would have any weird behavior or not, but you could definitely take this template. You can take this this message and you can maybe add some rigid body parameters in here. So, you know, you like your public float, rigid speed, and then, you know, give it your rigid body speed or whatever it is that you have to do. You can try it this way. Because remember, whenever you're dealing with physics, the physics are going to be dealt with on the server itself, because the server will have a copy of all the players and all the objects you're spawning. So just be careful of that. And if anybody does test that, don't be afraid to drop a comment and let me know how it works. So there you have it, guys. That's how I sync my movement, getting around Unity's crappy network transform. Thanks so much for tuning in, and I'll see you next time.